Cool. All right, so today it's all about implicit differentiation. And the game today is very similar to the chain rule. It's very much tied to the chain rule, the idea of the chain rule. Okay? But here's what's going to happen today. We're going to have a function that looks a lot like this guy. Or something. And you're like, Groom, what the heck? It's not y equals. What do you mean? It's not y equals. Oh, you're right. So if I could do this, y equals some function of x, then obviously y prime would just be the derivative of it, right? That would be it. But you're like, I can't do that, Groom, because I can't not get y by itself. But if you could, what are you saying? What I'm saying to you is I am implying that y is a function of x. I don't know what it is because I can't solve for y equals. Does that make sense? I can't do it. But I'm saying it is a function of x. It's theoretically possible. I can't do it. Okay? And I want to know how fast it's changing. Okay? Now, when I say implied or implicit, back in the day, you watch a TV program, and, the couple would go down the hall, and then the lights would dim, and then they'd come out, and there'd be like 2 or 3 little kids playing along, and you're like, oh, it was implied. Okay. What happened back there? Okay. It wasn't explicit. They didn't tell you exactly what happened back there. We didn't have to see it, for God's sakes. It was just implied. Okay, we've all had the birds and the bees talk, if you will. It's implied. So what we are implying is that y is some function of x. Groom, how are we going to do this then? Let me tell you, bud. What we're going to do here is this looks like a product to me because it's x times another function. Well, how do you do product rule? It's a good question, Joey. It's the first derivative times the second function plus the first function times the derivative. Now, what's the derivative of y? Now, some people would say y prime. Those people are not wrong, but we're going to write dy dx. That's how we do in implicit differentiation. Okay? We use Leibniz notation. Plus, now this guy is just 3x squared, so that's going to be 6x, obviously. Hey, what's the derivative of the sine of y? Well, the cosine of y. But wait a minute. This is a function in a function. So I need to multiply by the derivative of that inside function, which is dy dx. And of course, what's the derivative of a constant? It's 0, sir. Now, what we need to do is we need to get the parts that have dy dx on one side. So there's x of them here, and there's cosine of y of them here, and everybody else on the other side. And then we're going to solve for dy dx. So we say dy dx is this derivative. That's it. Well, but what's the slope, Groom? It's a good question, isn't it now? So what is the slope? Well, at a point, right? So at the point 1 comma something, let's actually put in 0. Let's put in 1 comma 0. No, well, just a minute. If I put in 0 for y, I get, and then, I get 3x squared is equal to 4, I guess. And so x squared would be equal to 4 over 3. So x would equal plus or minus 2 over the square root of 3. Okay? So at the point plus or minus, let's say 2 over root 3 comma 0. If I plug that into here, I would have a slope, yes? And so what is it? I don't know. Let's get a calculator out and see what happens here. So what is negative 6 times 2 divided by squirt 3 minus 0. I don't know, but it's probably negative. Divided by parentheses, this is 2 divided by squirt 3 plus 1. Because the cosine of 0 is 1, last I checked. So the answer is oh, for God's sakes. Clear. The answer it is this number here. So the answer is negative 3. Groom, can you graph that on Desmos? I'd love to. So in Desmos, if you come in here, it is x times y Now, this is, again, an implicitly defined function. So x times y, you have to times it out. Plus 3x squared. Plus sine of y. Equals 4. There's your function, dog. Whee! Whee! How exciting for us. Nice. Now, let's make sure that we are in radians. Where's the damn radians button at? Oh, radians. We are in radians. Good for us. And so there you have that scenario. Pause. Pause. Helps if you hit the home tab so it's on a normal screen. Anyway, there's our point, and clearly it has a -3 slope right there. You with me? Yay! And so Joe is like, how can I prove I'm right, Groom? Okay, well, we said the slope was -3 point whatever. So -3.21 or whatever I said. X minus some a value, right, is equal to y minus that b value. So in our case, it's y minus 0, -3.21. And then this was, our x was 2 over the square root of 3. If you do this, you will get your equation. So if I take times 2 divided by square root of 3, I get -3.7. Well, if I take this times this, I should take it positive. So I'm going to have -3.21x plus 3.7 basically is equal to y. And if you graph that, oh, it's basically tangent, yes? That's how you know you're right, Joey. That is how you know you're right. By the way, what would happen at positive over here on this side, right? It's the same value. See that? But it's 0, so -1. What's that going to have? I don't know. But you can plug it in over here and see what's up. Clear. Come back up here. For the love of Pete. That guy right there, if you take this and just come back and make that a negative right here, that becomes a negative, and then the top, of course, becomes a positive. You get a -44 slope. Well, that looks pretty steep negative, so yeah, I'd buy that for a nickel. Again, not very difficult. Implicit differentiation is really quite straightforward. Here is another that you might see on the homework, like for sure, man. How about this fella? E to the x times y equals 4x over y. Well, that's a good question. What about that one? This is fun. So this is a chain rule up in here, yes? So what's the derivative of e to the x? Well, it's e to the x times the derivative of this guy. But that is a product rule because y is implied to be a function of x. So it's going to be 1 times y plus x dy dx is equal to, now that's a quotient rule, right? That's a quotient rule. So 4 times, or I'm sorry, not 4. Come on. Yeah, 4 times y minus 4x times 1 over y squared. Oh, well, 1 dy dx. I almost forgot about that. What's the derivative of y? The derivative of y is dy dx. Okay. Here's the game. If you distribute this out, you get y e to the xy plus x e to the xy dy dx. Oops, dy dx. Is equal to, if you break this into two pieces, you're going to get 4 over y minus 4x over y squared dy dx. Now I need all the non-dy dx's on one side, so 4 over y minus y e to the xy. I need the rest of this garbage over here, so it's going to be x e to the y, and if I plus this, it's going to be plus 4x over y squared dy dx. And then literally, it is as easy as you think it is, divide by this business. Now, what we're going to spend some time with in the coming days is, hey, when you look at this, is there anything that x and y can't be or whatever, right? And remember, this has to be a point. So if you choose the point, like for instance, x can't be 0. Can you see that? How do I know that? Because if this were 0, this side would be 0. And e to any power can't be 0, can it? Right? That means x and y have to be positive as well. Obviously, y can't be 0 because why? Because if y was 0, then you'd be dividing by 0, and that is a problem. Yes? Furthermore, x and y could both be negative, but you couldn't have one negative and one positive because this would be a negative number, and e to any power is always going to be positive. Does that make sense? So x and y can't be 0. And either x and y are positive or x and y are negative, which means we're in the third quadrant or the first quadrant. Third quadrant or the first quadrant. It's one of the two. There's no ifs, ands, or buts about it. Oops. Oh, shut up. Also, that function looks odd to me, doesn't it? And when I say odd, I don't mean weird or queer looking. I mean it's odd because it's symmetric to the origin. Yes? If you look at it, that's the point 2, comma. But Groom, I can't, it doesn't like, you know, you can't just click on it. No, I know, right? So if they're both 0, that's a problem. But if you do that, now, by the way, when you do an implicit function like this, you can't zoom on it. But guess what's happening at 0? At 0, there's a hole or an asymptote. It's a hole, obviously, yes? Looks like the limit should be 0, but there's a hole there. Okay? Now, if you do this, all right, so on this side over here, let's say, for instance, it looks to me like at 2, well, at 1, rather. At 1, it looks like we're at about, we're at 1, comma 1.2-ish. You with me? Now, it's not exact, of course, but a guy could, if you did this, you could go, let's see, if I let x equal 1, for instance, could I solve for y? No, probably. And so, well, you could, or it might be easier to solve for x. Let's let y equal 1 instead. Let y equal 1. So if that were true, then it means e to the x is going to equal 4x. So e to the x all right, e to, oh, what in the hell? Yeah. So when you do that, you're going to get, they cross one another at the point 1.42 roughly. All right. Oh, fiddle faddle. All right, well, I let y equal 1. And so when I let y equal 1, that means I'm right here on this red line, right when it crosses the line y equals 1. That's literally what I did. And what I'm saying is where these guys cross right there is the point 0.3 whatever, comma 1, right? That's this point right here. You with me? 0.357, comma. Don't worry about that 0.142 part because we only said, hey, that's where our, we want to know where our x's are equal to each other, okay? And so if I did that, well, that means then that 0.3, whatever I said, 0.357 comma 1 is a point on this graph. Is a point on what graph? Is a point on the red graph. So if you put in right there, you see we're on the actual original graph, right? Positive or negative slope? Obviously, it's a positive slope. Yes, obviously. How I figured it out. Plug it into here. You with me? And so that's going to be 4 divided by 1 is 4. Minus e to the 0.357 divided by parentheses 0.357 times e to the 1 plus 4 times 0.357 divided by 1, which is just that, of course. And you get 1.07. 1.07. So again, what we're saying here is y minus 1 equals 1.07 x minus 0.357. And if you do the math on that, you're going to get 1.07 x distribute that out, 0.357 times 1.07, and then you're going to plus 1 to that, and you're going to get 1.38. This is how I know I'm right or not, because if I graph that, I should get a perfectly good tangent line there. So 1.07 x plus, what did I say? 1.38. And I think that's not going to work because I think I see where I made my mistake. Oops, 1.38. Groom, no. No. I feel like it's parallel. All right, it's perpendicular. That's the right slope. But Groom, you screwed up. Let's go see what I screwed up. Yes, because this should have been negative, yes? Let's try that again. So it's going to be 0.357 times negative 1.07 plus 1. Oh, lo and behold, 0.618. I bet it works this time. Oh, shut up! That's pretty good, right? That's the idea. That's what we're always checking ourselves. I cannot stress to you enough. I hate making stupid mistakes. I hate it, hate it, hate it, hate it, hate it. It annoys the bejesus out of me. Mr. Groom, can we find the slope of this guy? X squared plus y squared minus 4x squared equals 2x squared plus 2y squared. Yeah, I think I can. I mean, I don't know why I couldn't. Let's look at the graph. I almost graphed it on my other computer. That'd have been hilarious. Why can't you guys see it? Well, Groom, we're not on that computer, dummy. So x squared plus y squared. X squared plus y squared minus 4x. Oops. Minus 4x parentheses squared. Oh, dog. Equals 2x squared plus 2y squared. Oh, it's a limicone. How exciting for us. Back in my day, we had to memorize all this crap. You're welcome. Now, is there a problem right here at this point? Right there at that point on the far side right here, it's vertical slope. In other words, your denominator would be 0. Does that make sense? In our derivative in a minute, we're going to have a denominator, and it's going to have, at this point right here, which is like 5.5 or whatever, 5.5 comma 0, you're going to have a vertical line, won't you? And ditto here at 2.5. At 2.5 comma 0 roughly, you're going to have another vertical line. And at 0, 0, geez, at 0, you're going to have two different lines. One's positive slope, one's negative slope. That's cool. And then over here, right in that neighborhood, there's a vertical line. And ditto right there, yes? What about up here on the tippity top? Right on the tippity top, you should have a 0 slope, shouldn't you? And ditto on the bottom down here. Okay? So there's going to be interesting places. If I'm right in here, positive slope. From over here somewhere, negative slope. You with me? That's it. That's all we're going to be doing. It's easy money. Let's have a look-see. Hey, this is a chain rule. It's a function in a function. I know. So 2x squared plus y squared minus 4x to the first, right? Times 2x plus 2y dy dx minus 4 equals 4x plus 4y dy dx. Okay? And you're like, Groom, this looks ugly. Wow. Yeah, a little bit. Is it going to be hard to do? It's not going to be fun. Am I going to have to distribute this out? Yeah. Do I want to? I don't really. But I'm just going to man up and do it. First thing I'm going to do is I'm going to lose that 2. Make that a 2. I'm going to make this a 2. Because I can. All right, let's do this thing. So, if I take this and I FOIL it out, what will I get? Well, I will get 2x cubed plus 2x squared y dy dx minus 4x squared. And then take this, you're going to get plus 2xy squared plus 2y cubed dy dx minus 4y squared. And then minus 8xy minus minus 8x squared, sorry. Minus 8xy dy dx plus 16x equals 2x plus 2y dy dx. Well, I need my dy dx's on the same side, dog. And so I'm going to bring them all over here. I'm going to have 2x squared y of them, yes, plus 2y cubed of them, minus 8xy of them, minus 2y of them, all dy dx's. Are you with me? Everybody else, get out of the pool. Get on the other side of the thing. Anyway, so if I do that, I get 2x minus 2x cubed plus 4x squared minus 2xy squared plus 4y squared plus 8x squared plus 16x. Good night, nurse. I cross them out as I go because to me it's just easier. Oops, minus 16x. Sorry, mine. It's easier to keep track of that way. Nice. And then when I'm done, all I got to do, right there, Parker, 2x squared y plus 2y minus 8xy minus 2y. Like so. By the way, at 0, 0, is that a problem? Yes. Yes, it is, because what happens to your denominator? It goes to 0. Wait, so does your numerator. I know. Whoa, that's going to be kind of weird and trippy, man. Exactly. We saw from the graph that at 0, 0, we could have had a positive slope and a negative slope, which is kind of weird. That's what that's kind of telling us right there. And so, yeah, I can't really do much about it. I will say that there are, if you come look at the graph over here, there are 4 places up here somewhere, right up in there, 2, 3, 4 places where you have vertical asymptotes, yes? In other words, how many times could this denominator equal 0? 4 times. Whoa, yeah, man. And so if you solved it out, you could figure it out. Now, I'm not going to. I will tell you that one of them is approximately 5.75, no, 5.5, 0, 5.4, 0. Are you with me? Because right there, that's about 5.4 right there. Okay? And so if you put 5.4, 0 in there, you get very close to the denominator equaling 0. In fact, I can actually show you that. If I plug that in, I'm going to get 2 times 5.4 squared times 0. That's hot. And then plus 0. Oh, weird, Groom. Oh, and then, oh, look, and then 0, and then 0. Oh, everything goes away. Yay, the bottom is 0. Oh, no. If you're dividing by 0, what happens? You get infinity. Weird. And so, yeah, that's the game. Be very cool, very easy to do. Yeah, piece of cake. If you wanted to find out where it equaled 0 slopes, that'd be on the top and the bottom. It'd be roughly 2.5 comma 3, right? Roughly 2.5 comma 3. And so I suggest to you that if you plugged in 2.5 comma 3 into the numerator, I'm going to suggest that you get pretty darn close to 0. Let's see if that's true. 2 times 2.5 is 5. Minus 2 times 2.5 cubed. Right on. Plus 4 times 2.5 squared. Minus 2 times 2.5. 2.5. Now, Groom, you're just making that up. Well, no, I looked at the graph, ding dong. Times 9. Plus, and that's me, 4 times 9 is 36. Plus 8 times x squared. Minus 16 times 2.5. Well, it's pretty close to 0. Are you with me? It's pretty close to 0. It would have been exactly 0 if I'd had the exact point, right? I looked at the graph and said that looks awful like I went over 2.5 up to 3. Are you with me? Okay, that's where it looks like I ended up, but I'm not quite there. It looks like I need to be a little past 2.5, maybe, or maybe just a little below. Either one, I'm going to be in the ballpark. Actually, I'm going to say I need to be just a little beyond 2.5 because we still had a positive slope here. Are you with me? Well, I should say that. The top was positive 0.25. The bottom could have, come out negative, I guess. But whatever. So that's the game. We're not going to be doing a lot of that today. We're just going to be doing derivatives. So let me do a couple more examples, and then I'll turn you loose, and you can go have some fun. Oh, how about this one? 8 equals pi r squared times h. Whoa. That's hot, Groom. Hey, what's the derivative of 8? Well, nothing. And then what's the derivative of this? Well, it's going to be pi. It's going to be 2 pi r h plus, it's the product rule, pi r squared times d. Now remember, what we're saying here is h is a function of r, right? So I'm going to say dh dr. Okay? If I did this, then I'd be negative 2 pi r h divided by pi r squared is equal to dh dr. And you're left with negative 2h over r is how fast it's changing. This is how fast the height is changing as r changes. But what are you saying? What I'm saying is, dog, you've got a cylinder. Boop, boop, boop. It's got a volume that's equal to 8. For that 8 to not change, what had to happen? Well, as the radius gets bigger, the height has to get what? Smaller. So what this is saying is the height changes negatively as r increases. It's always as r increases. So as r is getting bigger, h is getting what? Smaller. Because what are we doing? We're holding the volume constant. Make sense? Now later on, you're like, Groom, can we change them both and have the volume increase? Yes, but not tonight, sir. Yes, we'll be doing that later on. It's very exciting, actually. It's very exciting. Here's a fun one. The sine of xt equals t. Shut up, Groom. That looks like what? Small angle. No. Yeah, wait. Check it out. So what we're saying is x is a function of t. We're implying that to be true. Okay? You could do it the other way around too, as far as that goes, but that's how I'm going to do it. Theoretically, t can be a function of x. That would make this problem a little grosser. But theoretically, that problem we did just a second ago, we did dh dr. We said, how does h change as the radius changes? We could just as easily have done this opposite. We could have let the height change and see what the radius does. In either case, they're going to be negative to one another. Yes, in that case. So in this case here, though, notice it doesn't equal a constant this time. Do you see that? It equals t, whatever t is. Okay, but t can change. And so let's keep that in mind. So if we do this problem, it's the outside function, so cosine of xt times the derivative of the inside. Well, that's a product rule, so 1 times t plus x dx dt. I'm sorry, Try again, Jay. Try it again. We said x is a function of t. So it's going to be dx dt times t plus x times 1 equals 1. Distribute. So cosine xt, and I'm going to put t out front, dx dt out back. That's how the big kids do. And plus x cosine xt equal 1. So I'm going to minus this over to the side. And then is equal to t cosine xt dx dt. And I'm just going to divide t cosine xt. Done. Done. Now let's see what that baby looks like. Sine of x times y. I'm going to use x times y. That's all we can do in here. Sine of x times y equals x. Wee. Mr. Groom. It looks like right here at x equals 0.975, comma 7.79 or something right there, we should have a zero slope. You're correct. That is correct, sir. That is correct. And so we're going to be looking at those. We're going to be taking a look at, hey, does that make sense? What's going on here? Everything on this side, the positive side of the x-axis, has negative slopes, except for that guy right on the bottom right there, right? Zero slope. On this side, they're all positive slopes, yes? Whee! Looks like a Christmas tree, kind of. Ooh, and then it gets funky and weird. That whole funky weirdness is the computer has to plot points. You saw me when I plugged in x and I had to solve for what y was. It's the same thing. It takes a lot of computing power to pull that off. All right, we'll talk more on Wednesday.